Hi guys, today we're going to be looking at a Venn diagram question. A certain number of learners are sitting for examinations in mathematics, tourism, and geography. All these learners sit for at least one of these examinations. The total number of learners who sit for mathematics, M, is 22. The total number of learners sitting for tourism is 16. The total number of learners sitting for geography is 18. 5 learners sit for math and tourism but not geography. 4 learners sit for mathematics and geography but not tourism. 3 learners sit for tourism and geography but not mathematics, and 6 learners sit for only tourism. Question 11.1. Draw a Venn diagram to represent all the learners sitting for these examinations. So in our Venn diagram, we would have obviously mathematics, tourism, and geography. So they say 6 learners sit only for tourism, so we know that one, so we can take that off. All the learners sit for one of these examinations, so we know that as well. 3 learners sit for tourism and geography but not mathematics. So tourism and geography but not mathematics. 4 learners sit for mathematics and geography but not tourism. So maths and geography but not tourism. So we've done these 2. And then 5 sit for maths and tourism but not geography. We then say that the total number of learners sitting for geography is 18. So for geography, we have 18 in total, but we still don't know our middle value. So the total number for tourism is 16. And so far for tourism, we have 5 plus 6, which is 11, plus 4, which is 14. So our remaining number must be 2. So now we can say total number for geography is 18. So 18 minus our 9 gives us 9. And then for math, we have 22. So 22 minus our 11 gives us 11. And this is our Venn diagram. Question 11.2. Calculate the probability that a learner chosen at random will sit for examinations in at least 2 of these subjects. So first, we need to calculate our total amount of learners, which we can say 11 plus 5 plus 2 plus 4 plus 9 plus 3 plus 6, which will give us 40 learners in total. We then want the probability that they will sit for at least 2 of the subjects. So we will take our 5, which is maths and tourism, our 4, maths and geography, our 3, tourism and geography, and 2, which sit for all 3. So we would have our 5 plus 4 plus 3 plus 2 all over our total amount of students. And this would give us 7 over 20, which is 0.35. Question 11.3. Determine if the events sitting for examinations in mathematics and sitting for examinations in tourism are independent. Support your answer with the necessary calculations. So to prove if they are independent, we need to say the probability of maths times the probability of tourism, and then separately get the probability of maths and tourism. And if these 2 values are equal, then we know that the events are independent. So if we say probability of maths times probability of tourism, we have the probability of maths being 22 over 40 and the probability of tourism being 16 over 40. And this gives us 0.22. Now we get the probability of maths and tourism, and this is maths and tourism, which is our 5 and our 2. So we have 7 over 40, which is 0.175. Therefore, the probability of maths times the probability of tourism is not equal to the probability of maths and tourism. Therefore, M and T events, so the maths and tourism events, are not independent. And that's all for this video. Thank you.